In this video, we'll be showing you the basics of computerized data acquisition using DataStudio or an Xplorer GLX, both of which are capable of using the same sensors.
When you open DataStudio, you will want to create an experiment. You'll need to tell DataStudio what types of sensors are connected and which ports on your interface they're connected to. Note that there are different types of interfaces, but that it's easy to tell if you have the right one selected because DataStudio shows a picture of it. Click the port you've attached a sensor to and select the type of sensor from the list. In this case, we've attached a rotary motion sensor to the first digital port and a voltage sensor to the first analog port. Next, you'll probably want to see what data you're acquiring. The most commonly used method of visualization is a graph. To display one, in this case, we will double-click on Graph and select Angular Position for the y-axis. Note that the rotary motion sensor is capable of measuring different quantities like angular velocity as well, but that they need to be enabled in the setup window if you want to use them. Note also that the x-axis defaults to time. For our example, we've attached a pendulum with a coil in it to a rotary motion sensor, and we'll observe its motion as it swings through a magnet.
Click Start and put the pendulum in motion. You will see the periodic waveform traced out on the graph. Click the Autoscale button to maximize the usage of visible graph space. Press Stop to end a run. If you press Start again, it will begin a second run with a different color. Note that the position of the rotary motion sensor at the moment when you press Start is considered to be 0, which is why our second run is not centered around the x-axis. Usually, it is desirable to view one run at a time, so you can uncheck data runs from the Data drop-down menu. This does not delete them, they are still in memory, and you can check them later to display them again.
Next, we'll increase the sample rate to achieve greater detail and add another graph to display the voltage. It is possible to double-click Graph and make a whole new graph, but in this case we'd prefer to lock the time axes together, so we will drag the voltage into the bottom left of the existing graph window. Again, we'll clear the existing runs. This time, when we press Start, data will be collected at the new sample rate. In most cases, you will want to export your data for use in Excel. To accomplish this, you can click File, then Export Data, select a run, and save it to the hard drive or an external drive. This will open a text file with 2 columns of data that can be opened in or imported into Excel.
Another potentially useful feature of DataStudio is the ability to zoom in on a particular region of interest. To do this, press the Zoom Select button, then click and drag the area you want to zoom into. This will automatically adjust the visible axis range to the highlighted area. If you want to check the actual value of a particular point, you can click the Smart Tool button and drag the box to the point in question. This will display the exact coordinates of that point.
Next, we'll give you a very quick introduction to some of the sensors you may encounter in the lab. This list is not exhaustive, and although most use of the sensors is intuitive, remember that some sensors will have the ability to measure some parameters that must be enabled in the DataStudio setup window.
This is a photo gate. It consists of a light source on one side of the gate and a light sensor on the other. When something blocks the space between the two, the photo gate sends a signal to DataStudio. This can be used for timing purposes or to start or stop a reading. Note that when the photo gate is blocked, a red light on the top goes on.
This is referred to as a motion sensor, but might be better called a position sensor. It reports the distance between the flat surface on the sensor and the nearest object to it. It works by emitting an ultrasonic pulse from the flat surface and detecting how long it takes to return after bouncing off of a target. Note that it has a minimum distance of 15 centimeters. There is also a switch to change from short distances, 2 meters or less, to standard, also used for poorly reflecting targets.
This is a force sensor. Unsurprisingly, it measures the force an object exerts on its hook. The sensor tends to drift over time, and as such, it's important to calibrate it before use. It's also important to zero it using the tare button on the front immediately before use. It can measure up to 50 newtons in either direction.
This is a magnetic field sensor. It measures the strength of the magnetic field at the tip of its probe. There is a switch on it that controls whether it is measuring radially or axially, there's a tare button to zero it, and there's a sensitivity switch that controls whether it is operating at 1 times, 10 times, or 100 times. This is a time-of-flight accessory. It consists of a piezoelectric transducer attached to a platform. When something strikes the platform, the transducer sends a pulse signal to the interface it's attached to. Similarly to a photo gate, this pulse can be used for timing purposes or to start or stop a measurement.
Now we'll show you some basics of the Xplorer GLX. This can be used as a standalone data acquisition device, essentially a substitute for a computer in DataStudio, or it can be used as an interface for DataStudio.
Here, we'll acquire some angular position data using our pendulum as before. Once you've turned on your GLX, you will need to attach the rotary motion sensor through a digital adapter and select it from the list that the GLX opens. As before, you'll want to display the data, and again, the most commonly used display is a graph. In this case, the y-axis defaults to voltage, so you'll need to press the checkmark button and change it to angular position. The play button on the GLX is used to start and stop a run. Press it and put the pendulum in motion, and you'll see data start to appear. As with DataStudio, the auto scale button is useful. Once you've acquired your data, you'll need to export it for analysis using Excel. To do this, select the Data Files icon. You'll need a USB drive to save your file on. Note that due to the age of the technology, it only supports drives up to 2 GB in size. When you plug in the drive, you should see it appear at the top of the Data Files screen. Press the left arrow twice to get back to the GLX's memory. If you haven't saved the file yet, you'll need to save it before you can copy it. You can do that by pressing File, then Save As, then choosing a file name. At that point, you can copy it by selecting File, then Copy File, then pressing Right twice to select the USB drive as a destination. The file is now stored on the USB drive as a DataStudio file. You can then open it with DataStudio and export it to an Excel-readable file as covered earlier.